Yeah, so this is a deck of cards, right? And we're going to use it to explore central tendencies. So I usually take out these colored. I only need the values, the ones with the values. So I put these aside. Yeah, so I have, yeah, you can see the numbers. I'm interested in the ones with the numbers. And I'll create a random system of numbers from it. So by crossing it a couple of times, I have a random system. Can you predict what the number will be? No. So this is a perfect way to learn central tendencies. So every day in most businesses, whatever transaction I'll book, you can't predict what the next customer will buy. So imagine these are customers coming to your business. How much does one buy? Maybe the person bought 2 CDs worth. The next person bought 7 CDs worth. The next person bought 7 CDs. The next person bought 10 CDs worth of goods. The next person bought 2 CDs worth of something. So 1, 2, 3, 4, 5. Let's say that today, this was the business day, and you're interested in finding how you did in your business. So what number will you say, will you assign to the business day? So what number will you say, will you choose as the value that represents the business activity for the day? It cannot be 2, 10, 7, no, none of these. So what you can do simply is by adding the figures. Yeah, so I have my quadrators to help me. Adding all of this up, what value am I going to get? So that'll be 2 plus 10 plus that will be 28. Obviously, to know how much I did on the business day on the average. So by dividing this 28 by 1, 2, 3, 4, 5 items, I'm going to have a fair idea. So the answer to this gives us something called, by summing all of them, we create what we call the sigma. And each of these represents an x, so the sigma of all the x divided by the number of times 1, 2, 3, 4, 5. And that gives me 28 over 5. So the simple answer is simplify to go into this 5 whole number and then remainder 3, right? So this will be the mean, 5 whole number, 3 over 5. This is what you call the arithmetic mean. This is one way that one can use to know how much they did on a good business day, on any business day. And we call this mean the central tendency. It means that this is what all these numbers are surrounded by. There's one number that surrounds all these, or all these numbers surround, and that is 5 whole number, 3 over 5. Another central tendency, instead of adding up, we would rather look at the figures and think, which one is the middle number? Now to find the middle number for this system, I need to rearrange this. I need to rearrange this by placing this here. Then the 7 to 10 will come this way because it's a larger figure, and the 2 comes here. By arranging this in order 1, 2, 3, 4, 5, 2 comes before 7, before 10. This system that I've created, realize that it's an odd system and it has a middle 7. So in other words, this becomes the central tendency, and it's called the median, because this is the middle number. The last central tendency we're going to look at is the mode. And the mode works by finding how many items, or the number of items that repeats the most. Notice that in this business day, 2, I made 2 sales of 2 CDs, as you can see, and then 2 sales of 7 CDs, right? And only 1 sale of 10 CDs. So in this case, the mode, which is the number of sales that I've done the most, will be 2 and 7. It means we don't have just one answer. The answers are 2. The mode is 2 and 7. It's bimodal. If there's only one number repeating more times, that would be single modal answer. And if, for example, there was only 7 repeating, then this would be the mode for the distribution. But for this distribution, the mode is both 2 and 7. Sometimes on a given business day, the manager, even before they receive the amount of money that all their customers came with on a given day, sometimes the manager can assume that, hey, today we're going to sell on average one person will buy up to, let's say, 6 CDs worth of items. And this is what the manager has in his mind. So this is what you call assume mean. So when the manager assumes a mean like this, it means that he could be right or wrong. And what we can do to be able to know whether he's right or wrong is to find the differences. So if the manager assumes that the mean is 6, then we have to create a table where So in today's distribution, we have our mark, our x values being 2, 7, and 10. And you can see that for the frequency, 2s are 2, 7s are 2, 10 is 1, right? And what we're going to do is that after obtaining the frequencies and the various x values on a table like this, we have to find the difference d, which is x minus the assumed mean. It means that the manager thinks that on a day we're going to make an average, one person on average buy 6 CDs, and this is what he actually bought. So we have to subtract each of these figures, each of these items that we have observed. We have to subtract the assumed mean from each of them. So sometimes you're going to get negative, other times you're going to get positive values. So the x value is 2. 2 minus 6 gives us minus 4. And then 7 minus 6 gives us 1. 10 minus 6 gives us 4, right? Yes. So this is, let me clean this, fortunately, and then write minus 4. So 2 minus 6 gives you minus 4. And the other 10 minus 6, or 7 minus 6 is 1. So this is the difference that the manager is recording for assuming that the sales is going to be 6. Obviously, we are not done. We need to create another system where we find the product of the F and D's. So let me excuse myself a bit. Yeah. So on my table, after assuming that we have we're going to make a daily sales of 6 CDs, we're going to extend the table by multiplying F by D. So F times D is minus 8, F times D will be 2, F times D will be 4. So this gives us the product of the frequency times the deviations that we record from assuming that the mean is 6. So this is what it's going to be. So what I'm going to do is I'm going to sigma all the F's. In other words, I'm going to add all the F's, and then what do I record? 2 plus 2, 4 plus 1, 5. So here I record a total of 5. I record a total of 5 here. And what about the FDs? So by adding minus 8 to 2 to 4, then I have 6 minus 8, and that's minus 2. So the sigma of all the FDs is minus 2, and the sigma of all the F's is 5. So to be able to find the mean, I have to add the assumed mean of 6 to the sigma of the FD, which is minus 2, over sigma F, which is 5. Right? And this is going to give me, it's 5 times 6 is 30, minus 2 all over 5. Right? So 30 minus 2 all over 5 gives me, and this gives me 28 over 5. If you remember, this was what we had for the mean, and we found the central tendency using the mean. We had 28 over 5, and it's come back to the same thing. So this is 5 whole number 3 over 5. That was the answer we had for the mean. Fascinating stuff. So this is when a manager guesses that the business will do well in a certain way, but he doesn't really have the facts. So when the facts come around, then he can find the mean using the assumed mean method, which essentially works on using the difference between the x and the assumed means. This is all there is to central tendencies. Hope you enjoyed the video. Catch you next time.